What we have seen before in the preceding section or the preceding lecture is reactions of primary amines with aldehydes and ketones to give the corresponding imines. What if secondary amines react now with aldehydes and ketones instead of primary amines? So the product is actually different. It's not an imine. It's actually what's called an enamine. So in this lecture now, we talk about the reaction of aldehydes and ketones with secondary amines to give the corresponding enamine. So if we draw a general structure of an aldehyde like that, so that's an aldehyde. If we react it with now a secondary amine, so that is a secondary amine. Please note the general structure. The pH is similar to that of the amine formation reactions. So what is actually produced in this case, not an imine, but actually an enamine. So this is an enamine. This is called an enamine, this product, because there is a double bond and there's an amine at the same time. So it's like ene coming from the alkene because there's a carbon-carbon double bond, so it's ene, and of course it is also amine, and that's why the name of this compound is enamine. But why is that so? Why does the outcome of this reaction lead to the enamine if we use, for example, a secondary amine instead of a primary amine? Why doesn't, for example, the reaction lead to an amine as we have seen before when aldehydes and ketones react with primary amines? Let's work out a mechanism in order to understand or to develop an appreciation of this specific and interesting reaction actually. So the first step is always a nucleophilic addition reaction between the amine and the aldehyde or the ketone. So the amine will now come and attacks that carbon of the carbonyl group in the general aldehyde in nucleophilic addition step. So we get this nucleophilic addition product. At this stage, an acid is not really required. We have water here, so water can come now and take off that hydrogen, just like what we have seen before when primary amines react with aldehydes and ketones. And please remember that if the pH is low, which means if the medium is really acidic or highly acidic, that's not really useful for this reaction because the acidic medium will cause or promote protonation of that secondary amine, which will not drive the reaction or which will not lead the reaction to the product that's desired in this case, which is the enamine. So highly acidic medium is not useful because it does not give the enamine product, but rather protonation of the amine, which is not useful in this reaction because that is not what's desired. So water will now come. It will take off that hydrogen. And of course, there was a positive charge before. It will take off that hydrogen, and the hydrogen-nitrogen bond will now be broken, releasing electrons to the positively charged nitrogen. So the product that we get, or the intermediate that we get, is this. And again, at this stage, the acid is not really important. Now we have formed some acid. There is some acid that's produced in this mechanistic step, which can be used in this step now to protonate that alkoxide. So we can show that by drawing the hydronium ion. So the alkoxide gets protonated by the hydronium ion, and the hydrogen oxygen bond is broken, releasing electrons to the positively charged oxygen. So what we can now write is the resultant intermediate, which is this one. And this intermediate, as you might expect, is called a hemiaminal, okay, just like what we have seen before in the reaction of primary amines with aldehydes and ketones. So this is called, again, a hemiaminal, as opposed to, for example, hemiacetal, again, as that what you've seen before in the reaction of aldehydes and ketones with alcohols. This is called hemiaminal because carbon has OH and an amine group. This hemiaminal now is an important intermediate, and some acid is really crucial here for the protonation of the OH, for the conversion of the OH into a much better leaving group, which is water. Therefore, some acid concentration is really required. Not too much of an acid, just like before, otherwise the protonation of the amine will take place, and not very little of an acid, because you want to drive the reaction forward, obviously. So protonation here is really important. So we can draw the hydronium ion like that, which will then be used to protonate this OH, in other words, conversion of the OH into a leaving group. So we can indicate that with this electron movement, we use a lone pair on oxygen to make a bond between oxygen and hydrogen, and this hydrogen-oxygen bond will now be broken, releasing electrons to the positively charged oxygen. We can then draw the resultant intermediate, which would be this one. And now we have OH2 or H2O basically, which is an excellent leaving group. And again, this protonation step sets the stage for the elimination of water from that intermediate now. The elimination of water can be facilitated, or better facilitated actually, by the lone pair on nitrogen. So that's the lone pair on nitrogen. We can use it actually now. We can use that lone pair on nitrogen to make a double bond between nitrogen and carbon, and simultaneously water is removed or eliminated. So in other words, the carbon-oxygen bond is now broken, giving electrons or releasing electrons on the positively charged oxygen. So this is the product that's produced. And now we have formed a carbon-nitrogen double bond as required, just like before, of course, as in the imine formation reaction. But we know already that the reaction will not stop at the imine stage because it's an enamine that is produced. Now, if you recall, this iminium ion, this is called an iminium ion intermediate. If you recall this iminium ion, and if you compare it with the iminium ion that you have seen before, you would notice the difference. And the difference is only actually on nitrogen. Before we had a group and hydrogen before, and now there are two groups on nitrogen, and there are two groups because these two groups come from the secondary amine. If you use a primary amine, there is only one group, but then you will get a hydrogen here. Now, at that stage in the imine formation reaction, that hydrogen was subsequently removed with a conjugate base to form the corresponding amine. Now there is no hydrogen to be removed on nitrogen. There is no hydrogen. These groups are actually alkyl groups or aryl groups which cannot be removed. So the conjugate base, being basic, will take the next possible, or if you like, the next possible acidic proton, which will be from the alpha hydrogen, alpha carbon, or the alpha hydrogen. That's the hydrogen that's located on the carbon adjacent to the imine functionality. So water will now come. So that is water. Now water will come and take off that hydrogen before in the imine formation, water came and took off that hydrogen, and therefore the imine was produced. Now water cannot go there because there is no hydrogen to be removed. There is no acidic hydrogen. Both of these are actually alkyl or aryl groups. So water will now come and take off this hydrogen, and as a result, this hydrogen carbon bond is broken and a double bond is formed between these two carbon atoms, and simultaneously this carbon nitrogen bond is broken, releasing electrons to nitrogen, and that's because nitrogen has a positive charge. It's like a driving force for this acid-base reaction. So water again comes, take off that hydrogen carbon bond is broken, a new carbon-carbon double bond is formed, and the carbon-nitrogen double bond is broken. That's because nitrogen is positively charged. So what's produced now is actually the final enamine product with release of the hydronium ion. It's like a catalyst. It's regenerated or recycled all the time. Now, to summarize this reaction, aldehydes and ketones react with secondary amines at a well-controlled acidity medium or pH 4 to 6 to give the corresponding enamine. Now, enamine is produced because at this intermediate, these two groups are actually alkyl groups now on nitrogen. It's not like you have hydrogen before. Therefore, formation of the imine will not be likely. Rather, formation of the enamine in the way we described takes place. So therefore, the enamine, an interesting function group which has a carbon-carbon double bond and an amine functionality are present in the same compound. It's therefore called enamine.